Welcome back, everybody. As you can sort of see, we're going to be doing technically from our current textbook two sections at once. That'll be very easy to do. We can kind of cover two sections at the same time, 2-6 and 2-7. And as you look at what I already have here on the screen, you can write down what's here in purple, but do not write down what's in red here, as is. Don't ignore what's in red for now, but you can feel free to write down, what's in purple. So these two sections are about absolute value functions and, the graphs of those functions. Okay? And something I might sort of, kind of touch on really quick right away is that this is going to be one of those, notes activities where, it's not what we do, at least 9 times out of 10, when we take notes, I just kind of lead you through the whole thing, start to finish, right? Hopefully with you participating as much as possible. But every once in a while, we kind of take notes by, you just kind of doing an activity, following some directions, and maybe you can discover what the mathematical concepts are that we're trying to learn, like the new mathematical concepts. And then of course, at the end of it, I don't just kind of leave you hanging. After you guys try the activities, try the notes, on your own or with a partner or two, then we kind of come back together, and I always would make sure that everyone sort of saw what they were supposed to see, right, by following the step-by-step instructions. So if you are at home because you were sick or whatever, just be aware that in class, and you should do the same thing. When I do this in class, I just kind of turn you loose, and then we kind of come together after you've attempted it. So that's what you should do now if you're at home and you're missing class. I will get you started. I'll at least explain what the deal here is, and what you're supposed to be doing as far as following the instructions. But then you should try the other, you should finish the graphs on your own. Pause the video and finish the graphs on your own to see if you can, see what I was supposed to be, getting across to you. But anyway, sorry, I shouldn't have rambled on too much about that aspect. But so these two sections are on, like I might have already said, absolute value functions and their graphs. Remember, a function can be represented by a graph, an equation, a table, right? A list of ordered pairs. I'm probably even forgetting about one or two, major ways. But so here's the function right here. F of x equals absolute value of x. It's an absolute value function. It's got absolute value in it, right? And remember that f of x is interchangeable with a y variable. So this equation that represents a function, can absolutely be written as, y equals the absolute value of x. And this one probably looks more normal, I suppose, to you, even at this stage, and aka also known as. So f of x equals absolute value of x, also known as y equals the absolute value of x. So it's a two-variable equation, and it represents a function. And we're going to be talking about the graph of this equation, of this function, right? Now, this cannot be the first time you have, investigated a graph or pieced together a graph by essentially making a table. You got this new, weird, unfamiliar type of XY equation, you might have no idea what the graph looks like, but you can sort of like, you can plot points and see what the graph would look like. So that's basically, finally getting to the point here, no pun intended. But that's what we're going to be doing here, basically. We're going to be essentially making a table. Now, I didn't really set it up exactly as a table. I have all these ordered pairs over here. So this, it's like, one of the points on this graph is going to be 0, comma, something. And you just have to figure out what that something is. And just like setting up a table with an X column and a Y column, all these numbers that are given here in the X spots, that's going to be like your X column. So basically, if you plug in 0 for X, what's that going to make Y equal? And it's going to make it 0, So when you plug in 0 for X, Y then equals 0, and therefore one of your points, on your graph, one of your solutions to this equation is 0, comma 0. So you'd put a dot right there. Okay? 1, if you plug in 1, what's the absolute value of 1? Because that's what Y is. Y equals the absolute value of whatever X is. So we're going to have 1, comma 1 right there. And what if I skipped ahead to like, negative 2? If you let X equal negative 2 and you plug in negative 2 for X, Y is going to equal the absolute value of negative 2. And remember that the absolute value of negative 2 is positive 2. So another one of these dots is negative 2, comma 2. Negative 2, comma 2. And so that's a point on the graph. Okay, so if you remember your absolute value, what absolute value means, I'm not going to be using, in this particular equation, I'm not going to be using any of those values. Like 4, comma 4. If you plugged in 4, you get 4, but if you plug in negative 4 for X, you also get 4. So not only is 4, comma 4 a solution and therefore a point, but so is negative 4, comma 4. And so, I'll go ahead and actually reveal what this is going to ultimately look like. And here is your final work, your final answer. We have all these points, and the graph of this equation turns out to be a V graph. It's basically the shape of a V. Okay? And keep in mind, and this is something that's true for probably any graph, okay, that's even similar to this at all. Notice how, this graph, I have arrow here, arrowhead, and an arrow here, because this graph goes on forever. Technically, there's how many points on this V graph? Technically, there's an infinite number of points on this graph. I mean, plugging in 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, that's not the only X values you can plug in. You can plug in 7. So if you plugged in 7, you'd get 7. So this graph keeps going because it's going to hit 7, comma 7. Over here, you could plug in negative 50. If you plugged in negative 50, you'd end up with the point negative 50, comma 50. So this part of the graph, keeps going and going and going until it hits negative 50, comma 50. But it keeps going even after that, And not only that, like I always say, these red dots that you already see and the blue graph you can see right in front of you, the red dots aren't the only ones. You could, look, you can plug in numbers other than nice integers. Why can't x equal like 2.5? If you plugged in 2.5, you'd end up with the point 2.5 comma 2.5. So there's a point there, and there's an infinite number of points just in this little space right here. Between 2 comma 2 and 3 comma 3, there's an infinite number of points just here. So, but again, like I said, that's pretty much true with I don't want to say like any graph, but most graphs you work with, that's true. This graph goes on forever. So here is the part of the lesson where, we might even be past the point here but this is where you would kind of like pause the video and, on your own without me holding your hand through it, you would basically complete this table, not a table, but it's essentially a table. Complete these points down here by plugging in all these values for x to see what you get, and then you can like make that graph, and then there's this graph, and then there's this graph. Okay, so there's like 6 more graphs, I believe, okay, that you're going to kind of just carefully plug in all these different x values and see what you get. Okay, so pause the video now and give that a try, and then unpause when you're done. Okay, so I hope, just to make sure that you did everything 100% correct, obviously this was the V graph from there, and it has what's called a vertex. So a V shape has this part where it kind of goes from going downhill and changes to going uphill, the little corner there. That's officially called the vertex. So write that down. I'm not going to write with my mouse here and look like an idiot, but look like a 3-year-old that just learned to write. 3 years old? When do you learn to write? Anyway, that's called a vertex. Okay, right here. So kind of maybe write that down. And these other equations, this one also formed a V graph, but not this, looks like this V graph was positioned a little lower than this V graph. I wonder why. Hint, 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 hint. And then there's this equation that ended up forming this V graph. And then next we had this one that, yep, another V graph, and it was this one. And then we had this V graph. And I wish I would have said this before I said pause, because I hope you weren't confused by how negative, like down here, -5 comma 7. How do I I mean, it's not that far out of bounds, but maybe it tripped you up a little bit, -5 comma 7, I don't know, but you were probably okay. But some of these points were a little bit out of bounds as far as this 5 by 5 by 5 by 5, space. But the point, like one of the big things is it's always a V. This one, -2 times the absolute value of x, that it formed this V. I'm still calling this a V, all right, even though it's upside down, And this was the graph of 1/2 times the absolute value of x. Okay, so hopefully you got all those graphs correct. So like I've already said a couple times, something that hopefully has jumped out at you, at least by now, because I pretty much said it, is that when you have an absolute value function, something involving the absolute value of x, or even the absolute value of x plus 2, or the absolute value of x minus 2, it involves absolute value, the graph of it is going to be a V shape, whether right side up or upside down, still it's that V shape. Okay? And something else I hope you noticed is that especially when you compare back to this first equation with its graph, because you should always compare back to this, because this, y equals the absolute value of x, or in other words, f of x equals the absolute value of x, this is what's actually known as a parent function. Hence the word families of functions over here. But, this plain as can be absolute value function, I mean, you can't get any more basic, any more plain, than just y equals the absolute value of x. That's called the parent function. And, it made this V graph that had a vertex at 0, 0, and the, slopes, for lack of a better word, I mean, there might not be a better word, the slopes of the V here are just like perfectly diagonal, up 1 over 1, up 1 over 1, up 1 over 1, and then in the other direction, up 1 over 1. So that is like your parent function with its parent starter graph. You can kind of compare all these other graphs, how they compare back to, the vertex, and how it like opens up. The V is right side up, in other words. And the slopes are just basically like 1, or, -1 technically. But so now you can like look at this and go, if we throw this -2 at the end of the equation, look what happened to the graph. It's essentially the same V. It's right side up. The slopes are basically up 1 over 1, up 1 over 1, up 1 over 1 in both directions, up 1 over 1, up 1 over 1. But the vertex, and therefore like the entire graph, moved down 2 spaces because of the -2 right there. And then look at this next one. Instead, we had a +2. So, if there was nothing there, like if there was, oops, come on. Of course. Of course. If there was nothing there, the vertex would have been here, But when you throw that +2, it moves from here up 2, and the slopes didn't have to change. Here, I want you to notice something. When we threw a +2 in there, like in the absolute value with the x, it actually made the graph move to the left. Write these things down, if you would. This, moved, this +2 moved the parent graph to the left 2 notches, which, here's the, baby elephant in the room right now, which seems backwards, that seems backwards. A +2, and we're moving to the left. Like over here, it's a -2 right in there in the absolute value, and it actually makes the graph move to the right. Yeah, So these little additions to the equations, when it causes a left or right shift, it's actually like backwards from what you would think makes sense. So this -2 makes it move to the right. This +2 makes it move to the left. And, if we want to go more in depth about why, then ask me in class. And hopefully I'm prepared to, give a good explanation. But the last couple graphs, check this out. So what happened with this graph? We had a negative 2 now multiplied to the absolute value of x. And this is what happened to the graph. What happened to the graph? I mean, obviously, it was flipped upside down. I think we've already mentioned that. So obviously, anyone can see it's been flipped upside down. Why do you think that is? Why do you think this graph ended up being upside down? Now, maybe you're guessing that because it was a negative number that was being multiplied, and that's it. There you go, bingo. If you have a negative number out here being multiplied to the absolute value, then it's going to flip your v upside down. And maybe you also noticed that the slopes are not just up 1 over 1, up 1 over 1. You know, it's actually like you can consider this negative 2, like not just the negative part turning it upside down, but the entire negative 2 is kind of like the slopes, you know? So notice how we go like down 2 over 1, down 2 over 1, and in both directions, down 2 over 1, you know? So kind of like back here, you know, you can think of it as there's an invisible number right there. There is a number right here out in front of the absolute value, and I'm sure you know that that is a 1. Like there's technically, and maybe going back all the way to here, there's an invisible 1 out here, and so the slopes are essentially 1. And not only that, I could even go deeper there, right? Is there a number being added or subtracted at the end here which would make it shift up or down? Like if there was a plus 4 out here, it would go up 4. If there was like a minus 7 at the end here, it would go down 7. But couldn't you say that technically this says plus 0? And so it didn't go up or down at all. It went up 0 and down 0. And then technically, you know, this says x minus 0 or x plus 0, whatever you want to think of it as, inside the absolute value, which means like it moved left or right, you know, 0 spaces. So anyway. And in this last example, just notice how this 1/2 out in front, that would be your new slope or slopes, where we go, again, up 1 over 2. I mean, literally the slope is 1/2. Up 1 over 2, up 1 over 2, up 1 over 2. In both directions because it's a v, up 1 over 2, up 1 over 2. And because that 1/2 is a positive number, this v graph is still right side up. It was not flipped upside down. So we can kind of summarize this in, let's see, I think I want you to write down maybe like this, because I think this is what matches your paper exactly, where it says vertex form at the end. So if you have an absolute value function equation, if it happens to be in and it pretty much always will be, but if it's in vertex form, where you have y or f of x, y equals some number times the absolute value of x minus some number, and then plus some number. Because of how we could like analyze the shifting, you know, like if this k was a 6, that means the vertex, and therefore the entire graph, moves up 6. And if this h value was like a 9, you know, and this said x minus 9, you know, that means like your graph would shift to the right 9 spaces. You know what I mean? So that's why like you can basically say that h comma k is your new vertex. Like, or not, I don't want to say new vertex, but that's going to be your vertex of your graph, you know? And I want to point out how, like, yes, that is a minus sign right there. And yes, that is a plus sign. That's not a mistake. That's how it goes. Because remember, this number right here, the graph shifts left or right. It's like the opposite of what you might think. That's kind of why there's a negative there. Think of it this way. If h was a -2, if h was a -2, that would make this overall x plus 2, because it would say x minus a -2. So overall, this would be x plus 2, which makes it move to the left. Okay, if this says x plus 2, it moves to the left. And again, your h value is -2 technically, because this negative is a part of, this minus is a part of the form, and so your h value is -2, meaning like you're moving to the left. And it's like when you got to like -2 comma whatever, your vertex is moving to the left. So that's why essentially that's a minus there and a plus there, because up or down does whatever. If k was a positive 7, you'd go up 7, but if k was a -7, this would essentially say -7, and you'd be going down. And like I already said, a is the slopes of the v graph, and if a is a negative number, the graph is upside down. And, it kind of goes without saying that if a is a positive number, it's not upside down. So that, I believe, is the big ideas for this whole like family of functions thing. So now you'd be able to maybe take any absolute value graph, especially if it was in vertex form, and just draw the graph really quick. Like as an example, here we go. I'm going to look like a 6-year-old here. Oh boy. Oh boy. You don't have to write this down, but just kind of like summarizing it here. If I wanted you to take this and graph it, you would just look at this and go, okay, it's a v. We got absolute value, so this is going to be a v. And, without the 5 and without the -2 and without the 3, it's like your standard parent v graph, but that starts at 0, 0 with your vertex and just has slopes of like up 1 over 1. But because of this -2 and because of this +5, your vertex shifts right 2 and up 5. So you'd put your vertex at 2, 5, and then you'd look at this 3 and you go, ooh. So now it's a positive 3, so my v is going to be opening up still, but the 3 changes the slopes, and so you're going to be going like up 3 over 1, up 3 over 1 in both directions. And that's what you would do to draw your v. You don't have to do, so now all of this plugging in numbers into a table or into all these ordered pairs, now that's officially antiquated. Now that's out of date, And this is going to be what you should do. You should just kind of like analyze the equation and how it differs from just plain old y equals the absolute value of x, and therefore what it does to the graph. And that is it for now.